This video is on types of numbers like factors, multiples, primes, square numbers, cube numbers and negative numbers. So first of all, factors. Factors of a number are everything that it can be divided by. So for example, factors of 20, I would list them in pairs starting with 1 and the number itself, because a lot of the time people forget about 1. 1 is a factor of every number because 1 divides into everything. So factors of 20, I would start with 1 goes into 20 times, 2 goes into 10 times, 3 doesn't go into it, and then 4 divides into it 5 times. After that then you would have 5 and 4 again, and you would start repeating yourself, so that's how you know you've got all the factors. So those are all the factors of 20, those are all the numbers that you can divide 20 by, or all the numbers that divide into 20. Then factors of 24 start again with 1 and the number itself. So 1 goes into 24 times, 2 goes into 12 times, 3 goes into 8 times, 4 goes into 6 times, 5 doesn't go into it, and then you're back to 6 and 4 again. If you're not very good with your tables, then yes, this will take you a wee while, but you'll still be able to get them all if you list them in pairs. Then, if you're asked for the highest common factor of 2 or 3 numbers, you would need to write out both lists like that, and then you would look for all of the numbers that they've got in common, like they've both got a 1, they've both got a 2, and they've both got a 4, but you're looking for the highest common factor, so that's the biggest number that they've got in common as a factor. So the biggest number that comes up in both lists there is the 4. So 4 would be the highest common factor of 20 and 24. You would never be asked for the lowest common factor because it would always be 1. Multiples then, these are your times table, so they're always going to be bigger than the number. So your multiples of 4, you start off with 4, and then you would have 8, 12, 16, 20, 24, 28, and so on. They would go on forever, so you'd never be asked to list all of the multiples. You'd maybe be asked for the first 4 or 5 or something like that. Your multiples of 6 are just all of the numbers in your 6 times tables. So start with 6, 12, 18, 24, 30, 36, and so on. Again, you would never be asked for all of them. Then your lowest common multiple of 2 or 3 numbers. If you're asked for the lowest common multiple of 4 and 6, you would list a few of each of their times tables and then look for the lowest one that they've got in common. So that's the first one that appears in common in both lists. So the first one that they've got in common would be 12. So 12 is your lowest common multiple of 4 and 6. You would never be asked for the highest common multiple because these numbers just go on forever, so there wouldn't actually be a highest one that they've got in common. Then your prime numbers. These are the awkward numbers that it seems like they don't really divide by any much, or by very much, because they only divide by 1 and themselves. So if you were starting with the first prime number, that would be 2. After that would be 3, 5, 7, 11. And that's because 2 only divides by 1 and 2. 3 only divides by 1 and 3, 5 only divides by 1 and 5, 7 only divides by 1 and 7, and 11 only divides by 1 and 11. They do go on forever after that, but those are the main ones that you would need. So 2 is the only one there that's even. All of the rest of these numbers are odd. So if you're asked, is this number a prime number? If it's even, you can automatically rule it out because 2 is the only one that's even and a prime number. That doesn't mean that if it's an odd number, it's automatically prime, because I left out an odd number there. I left out 9. So 9's an odd number, but it's not prime because you can divide it by 3. So the next one after 11 would be 13. It only divides by 1 and 13. The next number after that would be 15, but it's not a prime number because 3 and 5 both go into 15. So then after that would be 17. It doesn't divide by anything apart from 1 and 17. So I like to think of your prime numbers just as being the awkward ones that don't really seem to appear in any of your times tables because they only divide by 1 in themselves. That means that they've got 2 factors. So the factors here would be 1 and 2, 1 and 3, 1 and 5, 1 and 7, 1 and 11, 1 and 13, 1 and 17. And that's why 1 isn't a prime number, because 1 would only have one factor. It would just have 1 as a factor. So the first prime number is 2. Something that you're asked to do with your prime numbers sometimes is write a number as the product of its prime factors. So product means multiply, prime are those numbers that I was just listing there, and then factors are everything that it divides by. So you would start off with a number, this example is just the number 40. So you would start off with 40, and there's two different ways that you can do this. You can do it like a tree, where you do 2 wee branches coming out from 40, and down here you write 2 factors of 40. So something that you can break 40 up into, like 4 and 10, or 5 and 8, or 2 and 20, it doesn't matter. I'm going to go 2 and 20. And you circle any time you get a prime number. So any time one of these numbers comes up in the tree, then you circle it. And you don't break it up anymore, because 2 can only be broken up into 1 and 2, and you don't want any 1s in these trees. So go to 20 then, you could split it up into 2 and 10, 4 and 5. I'm going to go 2 and 10. Circle the 2 because it's prime, and then split the 10 up into 2 and 5, and then you circle both of those because they're both prime numbers. Once you have the end of all your branches circled, that's your working out finished, and then you just write the product of those, which is what you get whenever you multiply them all together. So you would have 2 times 2 times 2 times 5. And if you're asked to give your answer in index form, that means you just write 2 times 2 times 2 shorter. You write it as 2 cubed times 5. You don't actually multiply these back out again, because if you did, you would get back to 40. So 2 times 2 is 4 times 2 is 8 times 5 gets you back up to 40. That's the whole point of the question. You're writing 40 in a different way. You're writing it as the product of these prime factors. The other way for you to do it is by using a ladder and going like that and splitting it up. 2 to get you 20, divide by 2, get you 10, divide by 2, get you 5, and then divided by 5 will get you 1. And then the numbers that you use are down the side of the ladder. Doesn't matter which way you do it, you get exactly the same answer at the end. But I think most people prefer to use the tree method rather than the ladder method. The next type of numbers that I want to look at are square numbers. So these are the answer you get whenever you times a number by itself, and the reason they're called square numbers is because squares have sides that are the same length, and for you to get the area of it you multiply the length by the width. So you would be doing something like 5 times 5 or 8 times 8. So that's why they've called them square numbers. So 1 times 1 gets you 1, so that's your first square number. 2 2s are 4, 3 3s are 9, 4 4s are 16, 5 5s are 25. Then 6 6s, 36, 7 7s are 49, 8 8s are 64, 9 9s are 81, 10 10s are 100. You should know those ones off the top of your head, no problem, because you're expected to know up to your 10 times tables without having to work them out. These ones here, if you don't know beyond your 10 times tables, then you'll have to think of a way to help you remember them. So 11 times 11 is 121. 12 times 12 is 144. 13 times 13, I try to remember it. You've got 3's here, and your 3 times tables go 3, 6, 9. And then 14 times 14 is a bit like this number, but the 6 and the 9 are back to front, so it's 196. So there's the link between those two. Then 15 times 15, you're nearly done with your 100s there, so you're now up into your 200s. And then 25. So the wee pattern with that one is if you do 5 times 5, you get 25 there, and then you're up in your 200s. Okay, they would expect you to know all of those square numbers. Those 10 you should know off by heart anyway, and if you don't know these ones by now, then you would need to learn them because you're expected to know them. The square root then, that's the wee symbol. It looks a bit like a mixture between a tick and a dividing sign, so it looks like that. and this takes you back from your square numbers. So if you had a number like 36 underneath that square root, the square root of 36 is 6. So you just think what times what gets you the number underneath the square root, and the number that you pick, it has to be the same number that you're using twice. So the square root of 81 would be 9, because 9 times 9 gets you 81. Next sort of numbers then are your cube numbers. They are a wee bit like square numbers, except they've been multiplied by another number. So instead of you just doing 1 times 1, you times it by another 1 then after that. You still end up with 1. Then 2 times 2 times 2 gets you 8. So 2 times 2 gets you 4 times 2 gets you 8. 3 times 3 is 9 times 3 gets you 27. 4 times 4 is 16 times 4 gets you 64. 5 times 5 is 25 times by another 5 gets you 125. Again, they would expect you to know those first 5, and then possibly even beyond that they would expect you to be able to work out 6 cubed. Then the cube root takes you back from your cube numbers. So it looks a wee bit like a square root but has a wee 3 in there. That's your cube root. So the cube root of 125 is 5, because 5 times 5 times 5 gets you 125. And the cube root of 27 is 3, because 3 times 3 times 3 gets you 27. I forgot to say the reason why these are called cube numbers is because cube, it's like a 3D square, and the length and the breadth and the height are all the same. And if you were wanting to find the volume of that, you would do 4 times 4 times 4 to get you 64. One more thing then before we move on to the next type of numbers. Your cube numbers are the ones that have a wee 3 after them. So instead of it being written as 5 times 5 times 5, it's shortened down as 5 cubed. And instead of 5 times 5, you would say that as 5 squared with the wee 2 after it. So the 2 because you're multiplying 2 of them together, and the 3 because you're multiplying 3 of them together. So that's your square numbers and cube numbers. The last type of number that I want to look at then are your negative numbers. So these are any numbers that have the minus sign in front of them. If they don't have the minus sign in front of them, if they've got nothing in front of them, then they're automatically positive numbers. So the main place that you would come across your negative numbers are something like temperature. So if it's a very cold day, it could be like -2 degrees. So with your negative numbers, you can either think of it like a thermometer and move up and down the number line, or else you use the rule. And the rule that you use, it's here in the big box. You only use it whenever the two signs are right beside each other, or if you're multiplying or dividing. The rest of the time you don't use the rule, you just go up and down the number line. So your rule is, if you have the same signs, like they're both positive or both negative, you would get a positive answer. And if the signs are different, you would get a negative answer whenever you're multiplying or dividing. And if it's the case when you've got the two signs right beside each other, then you would replace two negatives with a positive, or replace the mixture with a negative. Okay, let's have a look at some examples then. So these examples here are ones where you would not use the rule, you would just go up or down your number line. So -5 up 8. I don't use the rule because the negative and the positive signs aren't right beside each other. There's a 5 stuck in between them and you're not multiplying or dividing. So -5, if I go over here to -5 and go up 8, so 1, 2, 3, 4, 5, 6, 7, 8, I end up at 3, a positive 3. So my answer here is 3. So even though one of them's negative and the other one's positive, you don't put the two of them together to get a negative answer. Because if you're down at -5 degrees and it gets 8 warmer, you end up at positive 3. Likewise here, if you've got -3 and you go down 1, so there's -3 down 1, you'll end up at -4. You don't put the negatives together there to make a positive because they're not right beside each other. 5 take away 7, so if you are up at 5 and you go down 1, 2, 3, 4, 5, 6, 7, you end up at -2. And the last one, -1 up 3. So if you're at -1 and you go up 1, 2, 3, you end up at a positive 2. So none of those examples there were using the rule because the signs weren't right beside each other and we weren't multiplying or dividing. The next few questions then, we are using the rule because they're all either multiplying or dividing, or the symbols, the adding and subtracting signs are right beside each other. So if you have 5 multiplied by -7, ignore the negative for a minute and just do 5 times 7 is 35. Then because one of them's positive and one of them's negative, your answer ends up being negative. The negative is like the stronger one of the two. It's the one that's always going to win out. So the negative would overtake the positive and your answer is negative. The next one, -8 divided by -2. Ignore the negatives and just do the dividing sum. So 8 divided by 2 would get you 4. And then they're both negatives, which will turn your answer into a positive answer. You don't necessarily have to put the plus sign in there. You can just leave it as a 4 if you want. So if there's just one negative, your answer is negative. If there's 2 negatives, your answer turns back into positive again. Then down here, you need to use the rule because you've got 2 negative signs beside each other there. So you need to know that the 2 negatives would turn into a positive sign. It would turn into a plus sign. So instead of -2 take away -6, those 2 negatives turn into an add, and you actually do -2 up 6, which you might need to go back to your number line for. So -2 up 1, 2, 3, 4, 5, 6. I end up at a positive 4 there. Doesn't matter whether you put the plus sign in there or not. And the last one, 3 add -7. You've got 2 signs there which look a wee bit confusing. So like the last question, you need to change them into a single sign. And the negative one is the one that wins out. So you just turn it into a single takeaway sign. So 3 take away 7. If you need to, go to your number line and go 3 take away 1, 2, 3, 4, 5, 6, 7. And you end up at -4 then. Okay, and that's the end of that video.